Have you ever wondered how the periodic table came to be? The journey began with early scientific minds striving to bring order to the chaotic world of elements. Pioneers like Antoine Laurent de Lavoisier, who dared to challenge the status quo, listed down 33 elements, categorizing them into gases, metals, non-metals, and earths. Then came along John Dalton, a man with a vision, who kick-started the practice of representing elements with symbols. These symbols, though simple in form, served as powerful tools, enabling scientists to communicate their findings universally. However, these initial attempts, though significant, were just the tip of the iceberg. The world of elements was vast and complex, and these classifications were merely scratching the surface. The scientific community knew that there was much more to discover, to explore. So the stage was set for someone to come up with a more organized way of classifying these elements. Enter Dmitri Mendeleev, the Russian chemist who took the world by storm with his periodic table. In the heart of the 19th century, Mendeleev was wrestling with a puzzle that had baffled scientists for decades. How could the known elements, each with its unique personality, be organized in a meaningful way? Mendeleev had a hunch. He saw patterns in the elements' properties when they were arranged according to their atomic weights. From hydrogen to uranium, he meticulously ordered them, not just in a simple list, but in a table. His table had horizontal rows and vertical columns, and in this magical layout, something extraordinary happened. Elements with similar properties found themselves grouped together. Like a cosmic game of musical chairs, everything fell into place. But here's where Mendeleev's genius truly shone. He noticed gaps in his table, places where it seemed an element should exist, but none had been discovered yet. Rather than seeing these as mistakes or anomalies, Mendeleev boldly declared that these gaps were placeholders for elements yet to be found. He even went a step further, predicting the properties of these undiscovered elements with astonishing accuracy. Mendeleev's table was a revelation, but it wasn't immediately embraced. Many scientists were skeptical, doubting the existence of these predicted elements. But as the years rolled on, one by one, the missing elements were discovered, and their properties matched Mendeleev's predictions almost perfectly. Gallium, scandium, germanium, just as he had foreseen. This uncanny accuracy transformed skepticism into awe, and Mendeleev's periodic table was accepted into the scientific community. Mendeleev's magic table was more than just a classification tool. It was a predictive map, an oracle of elements, illuminating the path for future discoveries. It was a testament to the power of scientific intuition, a bold leap of faith that expanded our understanding of the natural world. But as you might guess, the story doesn't end here. The periodic table would continue to evolve, adapting and growing with every new scientific discovery. But that's a tale for another scene. The periodic table, as we know it today, is the result of many additions and alterations. Our journey brings us to the 20th century, a time when the periodic table underwent significant changes. One of the most pivotal figures during this period was an English physicist by the name of Henry Moseley. Moseley introduced a concept that would forever change our understanding of the elements, the atomic number. Before Moseley, elements were arranged according to their atomic weight. However, there were inconsistencies. For instance, tellurium and iodine were out of order if one were to strictly follow atomic weights. Moseley's work provided a solution to this conundrum. He proposed that elements should be arranged based on their atomic number, which is the number of protons in an atom's nucleus. This simple yet profound concept rectified the anomalies and gave the periodic table a solid foundation. As the 20th century progressed, new elements were discovered, further expanding the periodic table. Among these were the noble gases, helium, neon, argon, krypton, xenon, and radon. These gases were initially overlooked due to their extremely low reactivity. However, once discovered, they found their rightful place in the periodic table, forming a new group. The journey didn't stop there. The discovery of the lanthanides and actinides, two series of elements often placed at the bottom of the table, added another layer of complexity. These elements, characterized by their filled or partially filled 4f and 5f orbitals, were an exciting addition, further enriching our understanding of the atomic world. The modern periodic table is not just a chart of elements, it is a vibrant representation of the atomic world, a testament to our ever-growing knowledge and understanding of the universe at its most fundamental level. It is a tool that continues to guide scientists in their quest to uncover the mysteries of the material world. And that's how we arrived at the modern periodic table, a testament to human curiosity and scientific progress. Opening. The periodic table today is more than just a chart. The periodic table is a dynamic tool that not only catalogs the elements we know, but also predicts those yet to be discovered. Scientists use this table as a compass to navigate the vast realm of elements, understanding their trends and properties. It's like a treasure map, guiding us to the potential goldmine of new elements. But it's not just about discovery. The periodic table is also a key to understanding the intricate dance of chemical reactions. It allows us to anticipate how elements might interact, change and combine, giving us a glimpse into the very fabric of matter. As we move forward, the periodic table continues to evolve. It's not a static piece of paper, but a living, breathing entity that grows with every new discovery. And so, our knowledge of the universe expands. Closing. The periodic table remains a work in progress as scientists continue to discover and create new elements. So, to recap, we have journeyed through the ages exploring how the classification of elements has evolved from the early attempts to Mendeleev's groundbreaking periodic table. We've delved into the intricacies of the modern periodic table, appreciating its logical arrangement that has stood the test of time. We've seen how it's not just a chart, but a dynamic tool that continues to grow, adapt, and provide invaluable insights into the nature of elements, their properties, and their interrelationships. From its humble beginnings, the periodic table has become a cornerstone of chemistry, an indispensable guide for scientists worldwide. Today, the periodic table is more than just a scientific artifact. It's a living testament to human curiosity, ingenuity, and our relentless pursuit of knowledge. It's fascinating to think about the journey of the periodic table, and even more exciting to ponder where it might go next. Thanks for joining us on this exploration of the periodic table's evolution.